All right, building on our 7.0 where we reviewed solving one-step, two-step equations, talked about simplifying first and then solving using one or two steps. We're going to add another type in here, and it's equations with variables on both sides. Meaning I could have like 3x plus 7 equals 2x minus 1. All right, so I have a variable. So if I divide my equation right down the center, I have a left side and a right side. And I can't just combine these like terms because I'm taking them from one side and moving it to the other. So what we're going to do is, first thing we're going to do is we're going to either add or subtract to get the variable terms on the same side. And it's dependent on, if I'm going to remove this, this is understood to be a positive 2x. So if I want to move that to the other side or inverse it to the other side, I have to subtract it from one side, right? So if I do that, right, if these are equal, I have to do the same thing to keep that equal on both sides, right? So then if we look, here I have 3x minus 2x, right? And that would be 1x, right? And I don't have to write the 1 there. And then I still have the plus 7 over here. Positive 2x and negative 2x cancel out, and then I'm left with negative 1. Now this should look like the equations that we looked at in section 7.0, right, or review of chapter 3. And this is a one-step, right? So solve the equation using one or two steps. Sometimes it might result in a two-step equation. Here it's just a one, right? Because here's my variable term. If I inverse 7, right? So that would cancel. I'd end up with x equals negative 1 minus 7 would be negative 8. Right? And then a good thing, it is an equation, right? It's equal. So I should be able to check it by plugging in what we said x is equal. So I'm going to take it and plug it in here, take it and plug it in here, right? So 3 instead of x, I'm going to type in negative 8 plus 7. I'm going to see what that equals, right? That's negative 24 plus 7 would give me negative 17. And then if I plugged in 2 instead of x, I put negative 8 minus 1, right? That would be negative 16 minus 1 equals negative 17. So you can see when I plug it into each side, the values are both negative 17. So that would be my solution. So that's what we're going to look at today. We're just adding this extra step where we have to get a variable from one side to the other, right? Notice they're not on the same side of the equation, and that's what we looked at yesterday. They're on separate sides, and we have to move it using addition or subtraction. All right, let's look at a couple examples. All right, so I have a variable term over here and a variable term over here. Now, it doesn't matter if you move the 2x over to the 3x or the 3x to the other side. And I'm going to show you both ways. But I'm going to look at this one first and show you that. See how there's a variable term and a number, right? Let's get the variable terms to the other side. So I'm going to start by, right, and this is understood to be a positive 2x. I'm going to subtract 2x from both sides. Right, so positive 2x and negative 2x cancel. So I'm left over here with a 3. 3x minus 2x is 1x. So I'm actually done solving right there, right? It's 1x equals 3. I've isolated the variable. All right, now, let me back out of there. And just show you the other way to do this, right? Because I know a lot of you, and me personally, I like to bring the variable to the left side of the equation. That's just a personal preference. But you got to be careful here, right? So if I'm going to move this, right, again, that's a positive 3x, so I'm going to subtract it from both sides. So here we have 2x minus 3x, right? That would give me negative 1x. Here I have plus 3. Over here I have nothing. I have 0. Okay. So what we've done is we've moved the variable to the left side. Well, now I have to solve it using a two-step equation, right? So I'm going to start here and go minus 3. So we'd get negative 1x. That would cancel. 0 minus 3 is negative 3. So here I have to divide by negative 1. And we get positive 1x, right? That would make a positive equals positive 3. So it can be done that way. However, you can see it took a few more steps. All right. All right, so left side and right. Again, let's keep to that method. So here we have a variable term and a number. Here we have a variable and a number. So it really doesn't matter which way we bring it. Let's move this positive 3x by subtracting it from both sides. So over here, 5x minus 3x is 2x, right? I still have that positive 4 over here, right? So this didn't cancel. I still had 2x's left after I did that operation. Nothing with the number is positive 4, right? Over here, positive 3x and negative 3x cancel, and I bring down that negative 2. So here's my variable term, right? I have multiplication and addition, so it's going to take me 2 steps to solve from here. So I want to inverse a positive 4 through subtraction, right? So here I'd have the 2x, 4 and negative 4 cancel. Negative 2 and negative 4 is negative 6. Divide both sides by 2, right? Because this is 2 times x. And negative 6 divided by positive 2 is negative 3, right? And again, integer rules apply here, but we're not always going to get integers. You can see number 3, right? We're not going to get integers. So you might want to have a calculator handy to help check your work here on problems that contain decimals. So start here, right? I have a number and a variable term, right? Number and a variable term. So it doesn't matter which way we bring the variable. I'm going to start, right, by writing this 1 in here. That's an understood 1a. Here, that's a positive 2.5a. So it does not matter which side you bring the variable to. So let's bring this 2.5 over. So I'm going to do that. It's positive, so I'm going to inverse that with a negative 2.5a. And I have to do that same thing over here. So I have 2.4. 1a minus 2.5a is going to be negative 1.5a, right? 1 minus 2.5 is negative 1.5. So that cancels here. Got to be careful and make sure that I bring down that sign, right? This is a negative 4.5. So my variable term is on the left. It's negative 1.5a. And I want to get rid of, right, that's understood to be a positive 2.4. So I'm going to subtract 2.4. So when we do that, right, the positive 2.4 and the negative 2.4 cancel. Bring down the sign with it. It's a negative 1.5a. Here we have negative 4.5 minus 2.4. That's going to be negative 6.9. So to finish this is times, right? So we have to finish that with division. So my negative 1.5 and negative 1.5 cancel, right? Negative divided by negative is positive a. Now, negative 6.9 divided by 1.5 should be positive 4.6. Right? And again, you could check that out by plugging it back in. But again, working with decimals and not just integers, you can do it by hand. All right, but it's okay to have your calculator handy to help you with problems like that. All right, so let's take a minute, and I want you to try. Okay, 1, 2, and 3. So pause the video here. All right, and remember, for each of these, you want to get your variables on the same side. Does not matter which side, right? I prefer to bring them to the left, but it's up to you. It doesn't matter, whatever your preference is, but solve for the variable. So pause here and check back in a minute. All right, let's check and see how you did, right? Number one, started off by subtracting 2x from both sides. You get 10x equals 40. So 10 times something, 10 times x. So we divide, should get x equals 4. Number two, I started off by subtracting 3x from both sides, right? So 4x minus 3x was 1x, okay? So there's understood to be a 1 there. I didn't write it because it's just x. And we had minus 1 equal 2. So to get rid of a minus 1, we had to add it to both sides, and we get x equals 3. Now, in number 3, notice how I wrote in the 1n and negative 1n there. And the reason I did that, and maybe some of you did this, I see this a lot, where you just go n plus n and you say that's equal to n, right? And you might have done that. That's a very, very common mistake. But remember, there's a coefficient of 1 on those. So when I add negative 1n, positive n, this side cancels. But here, 1n and 1n is actually 2n. Then you have 0.4. Over here, you're left with a positive 1, right? You don't really have to write that, but it's understood to be a positive 1. Make sure you're aware of the signs, right? This was a positive 0.4, so that came down with it. So from here, here's my variable term. I'm going to subtract 0.4 from both sides. So we get 2n equals 0.6. When we divide that by 2, we get n equals 0.3, or you'll see that written as 0.3 as well. All right, using equations to solve problems. All right, so the video store has 2 membership plans. All right, and it says plan A has a yearly membership of $30 plus $1.50 per rental. Right, so plan B has a yearly membership of $12 plus $3 for each rental. It says how many rentals will it take for the plans to result in the same yearly cost, right? So we want to find out when these plans are going to be equal to one another, right? So for plan A, if I just kind of read through this, it says it's $30 plus $1.50 per rental. So I'll say that's R. And then plan B has $12 plus $3 for each rental. Okay. So I can see that if I don't rent any movies, right, plan A is going to cost me $30 and plan B is going to cost me $12, right? If I have 0 rentals, it's whatever the yearly membership is. But then each time I rent a movie, they're getting closer to the same price because this costs more to rent, right? So at a certain point, right? So if we look on a graph, right, this one starts down here at 12 and it's moving up at $3 per rental. Where this one starts at 30, but it's not increasing each much. I'm only getting $1.50 per rental. So eventually they'll cross, right, at a certain number of rentals where they'll be the same price, and then this one will end up being more because then every time you rent, you're getting $3 for your charge. All right, so let's see when those are equal. So we want to start by getting our variable terms together, right? And again, you can move that one over here, this one over here. I like to put it to the left. That's just personal preference. So I'm going to go minus 3r from both sides. So over here we have 30. 150 minus 3 would be negative 150 r. Over here we would have 12. So that cancels out. So my variable term is here, right? This is a positive 30. So I'm going to subtract that from both sides. And we would get, cancel, negative 150r, right? I bring that sign with it. Here we would have negative 18. Now this is negative 150 times r, so I'm going to divide both sides by negative 150. So in my calculator, if I type in 18 divided by 150, I get r equals 12. Okay, so what does that tell me? That tells me if I rent 12 movies in a month, these two plans would cost the exact same. Okay, meaning I could plug in that 12, right? So I could do 12 plus 3 times 12, and that gives me $48. And if I did 30 plus 1.5 times 12, that would also give me $48. So 12 rentals, the plans would be the exact same cost. All right, practice problems. Please try these on a separate sheet of paper. All right, your numbers 10 to 26 even, and then some review problems, some of the percents from chapter 6, and then the distributive property, which will come into play in chapter 7. So make sure you're refreshed on that. If you have any questions, please shoot me an email. I hope you have a great day, and we'll talk to you soon.